So today we're looking at the problem solving chapter. First thing we start off with is percent. I'm sure you've all heard the term or familiar with it. In case you have not or need a little refresher, percent is essentially translated to part of 100. The easiest way to remember is 1 cent is 1/100th of a dollar. 1% is 1/100th of the whole thing. It can be translated to basically parts of 100. So for example, 40% is basically the same thing as the fraction 40 divided by 100, or 40 over 100, which can also be written in decimal form 0.40. Essentially, to convert from percent to decimal, you move the decimal place left 2 spaces. It should be that Sunday. Homework should be due on Sundays. So, start out with our first example. We have 683 people out of 800 people state that they like dogs. What percent is this? Well, question? We have 683 out of 800. I guess I should have done this first. Formula to calculate the percent is the part divided by the whole times 100. So in this case, the part is 683 out of the 800 people, which is the whole. So we do our calculations here. I have 683 divided by 800. 0.85375 times 100. And we have 85.375%. Okay? Everybody okay with that? Everybody got it? See a couple people still writing. Okay. So some examples here. Write the following values as percent. So essentially, I take 3, divide it by 4, and multiply by 100. 3/4 is 0.75 times 100 is 75%. Three-quarters, right? 3/4 is 3/4, 75 cents. Here we have 0.01. Essentially, if you have a decimal to convert it to percent, move to the right. So I have 1%. So to convert a percentage to a decimal, you move the decimal place 2 places to the left. To convert a decimal to a percentage, you move the decimal place 2 places to the right. I think there's one more on here, which again, 2 places to the right, 35%. If that was money, it'd be 35 cents, right? Same concept. Any questions on those three? Okay, so here we reiterate the percent equals the part divided by the whole. Also remember, when doing computations, we must write our percents as decimals. Most calculators will not multiply by percentages. You have to change it to a decimal. So the sales tax rate in Pensacola is 7.5%. How much tax will you pay on $319.99? So the first thing we need to do is consider this 7.5%. We need to convert that to decimals, which means right two places. So it is 0. Or left two places, I'm sorry, thank you. That's 0.075. That's 7.5%. Now what we want is how much tax will you pay on 319? So what we need to know is what is 7.5% of $319.99. So that is $319.99 times 0.075. $319.99 times 0.075 gives us 23.99925. Now we're talking about money here, right? So round to two decimal places. So to round this, I look at the next decimal place to the right. It's a 9. If it's 5 or above, I round up. So this becomes 10. So we put a 0 here, we add 1 here, and that becomes 10. So we put 0 here, and then we add 1. So we end up with $24. As far as rounding goes, if we're talking about money, you'll round to two decimal places. Other things, for the most part, I say two decimal places is the way to go. Unless it specifically says a different number. I think there is a test question later on that says 3. During your calculations, and not so much here, but later on when we get into some more complex calculations, I recommend not rounding until the end. If during the calculations you round to 3 places instead of 4, it could make a significant difference in the final outcome and some of the problems later on. Okay. So we have a 2004 BMW M3. It dropped in value from 14,000 to 12,000 over the past year. What percent decrease is this? So first we need to know what's the decrease. How much did the price or the value of it decrease? At 14,000 minus 12,000, which is 2,000. So again, we're looking for a percent. Which is part over whole times 100. So what's our part? What's the part? 2,000. The amount of the decrease. What's the whole? 14,000. Very good. And then multiply by 100 to get percentage. Then we end up with 2,000 divided by 14,000, which gives me 0.1428571,429. Maybe not that many decimal places necessarily. I would keep at least 4 during calculation. We're going to multiply that by 100, which gives me 14.2. Second decimal place here is going to round up because of 529. And that is a percentage. So that was our decrease, percent decrease in 1 year. Any questions on how we got that? Everybody got it? Okay. So now that we've done this, let's look at how to do this. So in the above example, the absolute change is the absolute value of the ending quantity minus the starting quantity. This is always a positive value. That's what the absolute value part does. That's what this implies. Whatever's in it, make it positive. You get a negative number when you subtract, make it positive. The relative change is the absolute change divided by the starting quantity, which is a percent change. The starting quantity often referred to as the base of the percent change. So suppose a stock drops in value by 60% 1 week, then increases in value the next week by 75%. Is the value higher or lower than where it started? What do you think? Decreases by 60%, then increases by 75%. It's going to be more or less? More? Let's look at it. Now, there is a way to do this with just variables, but I'm a firm believer in finding the simplest way to do things. So what I try to do is say, okay, let's let the original value be $100. I don't know what it is, but it could be that. It doesn't specifically say it's not. So now it says the stock drops in value by 60%. 60% of what? The original price, the $100, right? So the first thing we need to think about is 60%. You can't do a calculation with percentages, so I need to convert that to 0.60. And then 60% of 100 is simply 0.60 times 100, which is 60. Now that's how much the value dropped. So it was 100, it dropped by 60, so now it's 40, right? Everybody with me still? Now it says it increases in value by 75%. 75% of what? Of 40. So again, looking at 75%, moving your decimal place. So we need 75% of 40, which is 30. So it increased by 30 from $40 plus the $30 increase to the final price of $70. Anybody want to change their answer now? Slower, right? Original was 100, final is 70. You have to be careful with percentages. 75% of 40 is less than 60% of 100. Any questions on how it? Yes. I just made it up. I didn't know what the price was. So I could do it, just give it a variable, but it gets a little more complex that way. This way I have actual numbers I can look at. And as we'll see in a problem later on, 100 is a very good number to use when we're talking about percentages. That's right. You could make it 200. You could make it $47.37 if you want. But 100 is a nice round number to use. Everybody got this one? No more questions on it? Yes. And there is also a recording of it already posted in Canvas from many, many moons ago. But yeah, this should be posted by the end of the night, unless my system at home crashes. So number 6, a basketball player scores on 40% of his 2-point field goal attempts. %, we can convert that to 0.40, and 30% on the 3-point. 30%, we can convert that to 0.30. Suppose the player attempts 200 2-pointers and 100 1-pointers, or 3-pointers. Find the player's overall field goal percentage. Okay. So completed 40% of the 2-point shots, and there's 200 of them. So what is 40% of 200? 0.40 times 200, which is 80. And then they completed 30% of their 3-pointers, or 30% of the 100 3-point shots. 0.30 times 100. So they completed 30 of those. So how many shots did they complete or make? 80 plus 30 or 110. So they made 110 of their shots. How many shots did they take? Well, 200 plus 100, which is, of course, 300. So we're looking for a percentage. Remember, percent is the part over the whole times 100. Well, the total number of shots they took is 300. And the part is the ones they made, 110 times 100. So now we do our 110 divided by 300, and that gives us 0.3666 repeating times 100, which gives us 36.67%. Any questions on that? Give you a minute to get it down. Everybody got it down? Okay, now we talk about rate and ratios of two quantities. Or a rate is a ratio of two quantities, and a unit rate is a rate with a denominator of 1. So we're basically talking about fractions. Your car can drive 300 miles on a tank of 15 gallons. Express this as a rate in terms of miles per gallon. Miles per gallon basically means miles divided by gallons. So what do we have? 300 miles, 15 gallons, which is miles per gallon, 20 miles per gallon. This is really what the question is asking for, the ratio. But then we went and found a unit rate as well. A proportion is an equation showing the equivalence of two rates or ratios. This wants it expressed as a rate in terms of miles per gallon. So 300 miles per 15 gallons or 20 miles per gallon, either of those would work. It didn't say a unit, so you could stick with the original amount. Anything else? So does anybody remember how to solve this proportion equation? Cross multiply, yes. So we take 3 times x equals 5 times 9. So 3x equals 45. Divide both sides by 3 and I get x equals 15. And the thing is, you can use your calculator to test this. You can go 5 divided by 3, which is 1.66666 repeating. And then you can go 15 divided by 9, and you will get the same thing. You can test these to be sure you got it right. I see you straining. Everything okay? This is the calculation for this x right here. You cross multiply 3 times x, 3x, 5 times 9. So we have 3x equals 45. And then what I want to know is what 1x equals. So I divide both sides by 3 and get x equals 15. Okay? Let me know if you need me to slow down, please. I'm sorry? Yeah. You can guess if you want, but what if you guess wrong? You just keep guessing. It'd be easier just to do the simple multiplication. But I mean, that would work. Any other questions? Okay, so here we have another one. Again, simply cross multiply 6 times x, 2 times 4. 6x equals 8. Divide both sides by 6 and you get x equals 8 over 6. So 8 over 6. Personally, unless it says reduce it, I wouldn't. Now this is a fairly easy one to reduce, but later on we'll get to some that are a little more complex when we do probability. Unless it specifically tells you reduce to smallest terms, just leave it. It makes it easier for me. Everybody has the same thing as opposed to people reducing it. I get people that reduce it just once, twice, 3 times, and mess up. And it's just easier to leave it. This would be reduced to smallest terms. It would be acceptable if you did that. I would take this, but unless it specifically tells you put in decimal form, I highly recommend you do not. Because this answer here is exact. It's exactly the answer. Same with this one here. It's exactly the answer. This one is slightly off. Not much, but it's a little bit off. It is an estimate. And at some point, you're going to have to stop writing 3. So again, if it doesn't specifically say put in decimal form, leave it as a fraction. A map scale indicates that 1/2 inch on the map corresponds with 3 real miles. How many miles apart are 2 cities that are 2 1/4 inches apart? So what I'm going to do here is I'm going to convert these to decimal because they convert exactly. I'm not losing anything by doing this. 1/2 is 0.50. 2 1/4 is 2.25, $2.25. So now I have 0.50 is to 3 miles, as 2.25 is to how many miles? I don't know. Let's find out. So I cross multiply. I get 0.50 times x equals 3 times 2.25. So 0.50x equals 6.75. I divide both sides by the 0.50. And I get x equals 13.50. And that's what, miles? Any questions how we did that? The font's not moving. Oh yeah, it is. It's just about an hour and 10 minutes ahead. Everybody got those two? Yes? Proportion problems can also be solved using dimensional analysis, process of multiplying a quantity by rates to change the units. So if you recall from example 7, your car can drive 20 miles per gallon. What we want to know is how far can it drive on 40 gallons? Well, if I can drive 20 miles per 1 gallon, how many miles can I travel on 40 gallons? So same thing, cross multiply. I get 20 times 40 and 1 times x. 800 miles. Any questions on that part? Okay, next we want to know how many gallons are needed to drive 50 miles. Well, if I get 20 miles for 1 gallon, how many miles? Nope. If I go 50 miles, how many gallons will I need? So again, cross multiplying. 20 times x equals 1 times 50. 20x equals 50. Dividing by 20, we get x equals 2.5 gallons. Of course, we don't need to do this math anymore because our cars do it for us. Any questions on that one? That's a relatively easy one. The next one's a little more complex. Everybody got it? So we have a bicycle traveling 15 miles per hour. How many feet will it cover in 30 seconds? So what do I know? It's traveling 15 miles in 1 hour. Okay? So 1 hour has 60 minutes. And note, this causes the hours to go away. So now I'm looking at miles per minute. 1 minute has 60 seconds. So now the minutes are gone as well. Now I'm looking at miles per second. And we want 30 seconds over an understood 1. The seconds cancel out. Now I'm looking at strictly miles. And the amount of miles in 30 seconds. But it wants feet. There are 5,280 feet in a mile, unless they lied to me last time. So this mile cancels out this mile. So now I take 15 times 1 times 1 times 30 times 5,280. That's my numerator. Then I have 1 times 60 times 60 times 1 times 1. Well, the bottom is 3,600. Let's see what the top is. Now 15 times 1 times 1 times 30 times 5,280 gives me 2,376,000. Then divide by the 3,600. And we get 660 feet. So in 30 seconds, our bicyclist travels 660 feet. Any questions on how that works? Okay, let's run through it again. So we know that we're traveling at 15 miles in 1 hour, right? But I want to know how many feet I travel in seconds. So I need to get this hour here converted to seconds. So 1 hour has 60 minutes, all right? Now this over this cancels out, which is our goal. Then 1 minute has 60 seconds. So now this minute and this minute. So now if I multiply across, I get miles per second. I want to know miles per 30 seconds. So now I multiply by 30 seconds, which is essentially 30 over 1. And this causes those to cancel out. Now I'm looking at strictly miles. Essentially how many miles I would travel in 30 seconds. But that's not what it wants. It wants how many feet. So I need to say, okay, 1 mile contains 5,280 feet. This causes this and this to cancel out. And now my only measurement is feet. And when you multiply across, you multiply to 15 times 1 times 1 times 30 times 5,280. And on the bottom, you multiply 1, 60, 61, and 1. And you get this here. Then you divide the numerator by the denominator, and you get 660 feet. Did that help any? Sorry? Didn't help? Who's saying no? Where'd we lose you? What I'm trying to do is convert this hour. I travel 15 minutes in 1 hour, or 15 miles in 1 hour. What I need to do is figure out how far I travel in 1 second, or in particular 30 seconds. So to do that, I take 1 hour is 60 minutes. Okay? So the hours go away, and now I'm left with 15 miles in 60 minutes. Well, I don't want minutes, I want seconds. So 1 minute is 60 seconds, or 60 seconds. So that kills the minutes. And now I'm looking at miles per second. But then I want to know for 30 seconds. So at this point here, it's miles per second. To find out how many miles I travel in 30 seconds, I multiply by 30. 30 seconds. So then the seconds go away. At this point, my unit of measure is strictly miles. However, It wants feet. So there are 5,280 feet in 1 mile. So this mile here cancels this mile here, and I'm left with a unit of measure of feet, which is what I want. So then I take all the numerators and multiply them, and I get this. Then I take all my denominators and multiply them, and I get this. Then I take this and divide it by this, and I get that. Okay? I always bring up pizzas. If a 12-inch diameter pizza requires 10 ounces of dough, how much dough is needed for a 16-inch pizza? Yeah, we'll call it X. Use the formula for the area of a circle. So the area of a circle is pi, which is a constant. You probably have a button on your calculator somewhere. Times r squared. Does anybody know what the r stands for? The radius. What is the radius of a 12-inch diameter pizza? Anybody remember? 6? Yes. So here my radius is 6, and here my radius is what? 8. So now looking at the area of my 12-inch pizza, it is pi times 6 squared, or 36 pi. Now I know what you want to do. You want to go ahead and use that button on your calculator, but you don't need to. Just leave it. Here our area is pi times 8 squared, which is 64 pi. So now we have the area of the pizza, 10 ounces of dough. How many ounces of dough? So we can set up a proportion equation. So 10 ounces is the 36 pi square inches of pizza, as X, our unknown, is the 64 pi square inches of pizza. Okay? Any questions so far? And set up the proportion equation. That's the hard part. Then we solve it by cross multiplying. So here I have the radius is 1/2 the diameter. So cross multiplying, I have 10 times 64 pi equals 36 pi times X. So this becomes 640 times pi. This stays as 36x times pi. So as I said, you don't need to multiply by pi, because what are we going to do now? Divide both sides by pi. So this is just 640, and this is 36x. Now we divide 640 by 36, and I get 17.7777, repeating. I would round it to 17.78 ounces. Everybody good? Getting in the home stretch here. I skipped this one last time too. A website says you will need 48 50-pound bags to fill an 8 feet by 8 feet by 1 feet sandbox. 48 bags. How many bags of sand would you need to fill a sandbox that measures 6 feet by 4 feet by 1 feet? Well, in case you don't know, volume is length times width times height, which is what these measures are. So the volume here is 8 times 8 times 1, 64 cubic feet. The volume here is 6 times 4 times 1, which is 24 cubic feet. So we're doing the same thing, setting up a proportion equation. We have 48 bags is the 64 cubic feet, as X bags is the 24 cubic feet. Again, we're cross multiplying. I have 48 times 24 equals 64 times X. Helps to turn it on first. This is 1,152 equals 64 times X. We divide both sides by 64. And I get X equals 18 bags. Any questions? Anybody got it? Is it warm in here or is it just me? Thought maybe I was going insane. Question? Bless you. Ready to move on? I take 1152 and divide it by 64. Yeah. Whenever you have something times X, to find out what X is, you divide by that on both sides. Okay? So now that we've done 9 pages of examples, we'll go over how to solve a problem. So the first one is probably the most important thing on here. Identify the question you are trying to answer. I have had students in this class work a problem of a page of work and then not answer the right question. It happens a lot in the finance chapter. The finance chapter. Next, identify the information you will need and the relationships you will use to answer that question. Essentially, like the formulas for the area of the pizza or the volume of the boxes. That information will either be that I was actually getting to that. The formulas and any information that you need to solve the problem will be given to you. You're not going to need to, well, that comes up in number 4. Number 3 is try working backwards, creating a solution pathway. I still haven't figured out exactly what that means, but if you know, feel free to do that. And then it says, if you're missing necessary information, look it up or estimate it. You will never be missing any important information on a test. You'll have it. Now, homework you might, because you have the ability to look stuff up. Yes. No. Your exams are free answer. What that does is that allows me to give you partial credit. I give you multiple choice, it's either right or wrong. So you get 0 or 10, or 0 or 5. And then solve the problem following your solution pathway. So, suppose your heart beats 80 times per minute. How many times does your heart beat per year? Well, let's work through it. 80 beats per minute, right? Now, there are 60 minutes and 1 hour. So what this does is get rid of the minutes, and now I have so many beats per hour. 1 hour, oops, backwards. There are 24 hours in 1 day. They hadn't changed it yet. What this does is get rid of the hours, and now I'm looking at beats per day. And it's not leap year, so there are 365 days in 1 year. So this cancels this out. So I'm looking at beats per year, which is what I want. Now to calculate this, we multiply all the numerators, 80, 60, 24, and 365. I'm sorry. And all the denominators, which are just 1. So we take 80 times 60 times 24 times 365, and we get 42,048,000 beats per year. That's a lot of beats. Then realize your heart only has so many beats in it. So. Any questions on how we did that? Everybody's good? Okay, this next one is similar to the stock one. Store has clearance items that have been marked down by 50%. They're having a sale advertising an additional 30% off all clearance items. What percent of the original price do you end up paying? So again, there are ways to do this using variables, but why? Why make it more difficult than it needs to be? So again, original price, $100. I can say that it could be that, might be 200, might be 700, might be $1.25, I don't know, but 100 will work. Now, it says they're marked down by 50%. 50% is 0.50, and that was 50% of the original price, which is $50. So I marked it down this 50. Now, I keep meaning to change this problem and I keep forgetting. In this case, it didn't matter, but it does normally. So take this 50 and subtract it from your original price. And then you have a price of 50. All right? $50 markdown from $100 is 50. I guess I could do 200, but there's a reason I use 100, and you'll see that at the end. Now they're having another sale and marking off another 30%. Again, 30% of what? 30% of this 50. So 30% times 50 is 15. So that's a $15 markdown from this 50, which leaves us at 35% or $35. So that's our final price. Remember, percent is the part over the whole times 100. Well, the part is 35. I keep getting ahead of myself. The part is $35. The whole is $100 times 100. 0.35 times 100. 35%. And now do you see why I use 100 as the original price? It makes it a little easier. And it could be 100, we don't know. It could be anything. 100 works out nice then. Any questions on that one? Two more to go. Another car traveling 100 kilometers per hour. How far does it travel in 5 seconds? So we are traveling 100 kilometers in 1 hour. I'm looking for seconds. So 1 hour contains 60 minutes. That gets rid of the hours. So now I'm looking at kilometers per minute. 1 minute equals 60 seconds. That gets rid of the minutes. So now I'm looking at kilometers per second. But I want to know how far in 5 seconds. So we multiply by 5 seconds. The seconds go away. Now I'm just looking at kilometers. So I multiply my numerators. 100 times 1 times 1 times 5 over 1 times 60 times 60 times an understood 1. I get what? 500 over 3,600. Get my calculator out. And I end up with 0.1388. Repeating, we'll round it here. Round here, so we look here and it rounds up to 9, which is 0.1389 kilometers in 5 seconds. Okay? Any questions on that one? See a couple people still writing. We good? Last one. Some of you might know the answer to this without doing any calculations at all. A flash of lightning travels at the speed of light, which is about 186,000 miles per second. The sound of lightning, commonly referred to as thunder, travels at the speed of sound, which is about 750 miles per hour. If you see a flash of lightning, then hear the thunder 5 seconds later, how far away is the lightning? So the reality is we don't need this information here, mainly because it's basically instantaneous. If lightning flashes, you're going to see, if you can see it, it's going to be pretty much instantaneous. So basically what we need to know is how far does sound travel in 5 seconds? Nobody remembers the old wives' tale? I know I have some students in here a little older than the rest. You don't remember that? How far is it? But what was the saying? Every 5 seconds. Very good. Okay, so we have 750. And now these numbers are real, not made up. Something like that. 750 miles in 1 hour. Okay. I need miles per second. So 1 hour is 60 minutes. And that gets rid of the hours. And now I'm looking at miles per minute. 1 minute is 60 seconds. So that gets rid of these. Now I'm looking at miles per second, and I have 5 seconds over an understood 1. So now I'm looking at strictly miles. So I multiply my numerators, 750 times 1 times 1 times 5 over my denominators, 1 times 60 times 60 times 1. And what is it? 3750 over 3,600, which rounds to 2 decimal places to 1.04 miles. Any questions? Everybody's good? All right, let me stop the recording.